There is a hormone quietly declining in millions of men, and increasingly in women, and most of them have no idea it is happening. Testosterone. Not because of aging alone, not because of some unavoidable genetic fate, but because of something sitting in the kitchen right now. Studies show that a single high-sugar meal can suppress circulating testosterone levels by up to 25% for several hours afterward, not over years of poor eating. After one meal, and for people consuming added sugar multiple times every single day, that suppression is not a temporary dip. It becomes a chronic baseline that shapes energy, body composition, mood, libido, and long-term health in ways that a standard blood panel rarely catches early enough to matter. The relationship between sugar and testosterone is one of the most underreported findings in modern endocrinology, the science of hormones. It involves insulin, inflammation, cortisol, and the very factories inside the body that produce testosterone in the first place. Over the next 12 minutes, we are going to trace exactly what happens and what begins to change when sugar leaves the picture. Section 1. What testosterone actually does, beyond the obvious. Before we trace the damage, let's establish what testosterone actually is and why it matters far beyond the narrow way it is usually discussed. Testosterone is a steroid hormone, a chemical messenger built from cholesterol, produced primarily in the testes in men and in smaller but significant quantities in the ovaries and adrenal glands in women. It belongs to a class of hormones called androgens, which regulate the development and maintenance of male characteristics, but whose influence extends across every human body, regardless of sex. In men, testosterone governs muscle protein synthesis, the process of building and maintaining muscle tissue, bone mineral density, red blood cell production, cognitive sharpness, motivation, mood stability, and sexual function. In women, it plays a critical role in libido, bone health, energy, and emotional resilience. In both, it is a key regulator of metabolic rate, how efficiently the body burns fuel at rest. Research shows that testosterone levels have been declining across Western populations for decades, independent of aging. A 40-year-old man today has measurably lower average testosterone than a 40-year-old man in 1980. Identifying why requires looking at what has changed most dramatically in the same period. Diet, and specifically added sugar consumption, is near the top of that list. Section 2. How sugar suppresses testosterone, the insulin pathway. Now, let's follow the mechanism precisely, because understanding this chain reaction is what makes the sugar-testosterone connection impossible to dismiss as coincidence. It begins with insulin. When you consume sugar or refined carbohydrates, blood glucose rises rapidly. The pancreas, the gland that regulates blood sugar, responds by releasing insulin, the hormone that signals cells to absorb glucose from the blood. This is normal and necessary. But insulin does more than regulate blood sugar. It directly interacts with the cells responsible for producing testosterone. In the testes, specialized cells called Leydig cells are the primary manufacturers of testosterone. Research shows that chronically elevated insulin, the condition that develops from repeated high sugar intake, impairs Leydig cell function. The cells become less responsive, produce less testosterone, and the entire hormonal output of the system decreases. Studies in both animal models and human subjects show a clear inverse relationship between insulin resistance, the state where cells stop responding efficiently to insulin, requiring more and more of it, and testosterone levels. As insulin resistance increases, testosterone falls. This is not a minor correlation. It is a direct biological mechanism, and it operates continuously in every person whose diet keeps insulin chronically elevated throughout the day. Section 3. The fat cell problem, estrogen, sugar, and the conversion equation. Here is something that surprises most people because it reveals a second mechanism working simultaneously with the insulin pathway. Excess sugar consumption promotes fat storage, particularly visceral fat, the deep abdominal fat that accumulates around internal organs. And visceral fat is not metabolically inert, it is hormonally active tissue. Fat cells contain an enzyme called aromatase. Aromatase converts testosterone into estrogen, the primary female sex hormone. The more visceral fat a person carries, the more aromatase activity occurs, and the more testosterone is continuously converted away before it can perform its functions. This creates a compounding cycle. High sugar drives fat accumulation. Fat accumulation drives aromatase activity. Aromatase activity reduces testosterone and raises estrogen, and elevated estrogen in men further suppresses the hormonal signals that tell the body to produce more testosterone in the first place. Research shows that men with higher levels of visceral fat have significantly lower testosterone and higher estrogen ratios, regardless of total body weight. A person can be only moderately overweight and still be caught in this hormonal loop if their fat is concentrated in the abdominal region, which is precisely the pattern that high sugar, high insulin diets preferentially produce. Removing sugar addresses the root of this cycle at its origin point. Section 4. Cortisol, the third mechanism. Nobody mentions. There is a third pathway connecting sugar and testosterone that receives almost no attention in popular health content, and it may be the most insidious of all. It runs through cortisol, the body's primary stress hormone, produced by the adrenal glands sitting atop the kidneys. Cortisol and testosterone are biologically antagonistic, meaning when one rises, the other tends to fall. This relationship exists because both hormones are manufactured from the same raw material, cholesterol. When the body is under stress and demands more cortisol, resources are diverted away from testosterone production. Researchers sometimes call this the pregnenolone steal, the diversion of the shared hormonal precursor toward cortisol at the expense of sex hormones. Here is where sugar enters. Blood sugar crashes, the reactive hypoglycemia that follows a sugar spike. Trigger a cortisol response. The body interprets a sudden drop in blood glucose as a physiological emergency and releases cortisol to mobilize stored energy. People who consume sugar multiple times daily are inducing this cortisol response repeatedly throughout the day. Each cortisol spike is simultaneously a testosterone suppression event. Studies suggest that chronically elevated cortisol is one of the strongest predictors of low testosterone in otherwise healthy men, and the sugar-driven blood sugar roller coaster is one of its most consistent modern causes. Section 5. The first 2 weeks without sugar. What the body begins doing. Now, let's move through time, because the recovery timeline is as important as the damage mechanism. What actually happens inside the endocrine system, the hormone-producing network, when sugar is removed? In the first 3 days, the most immediate change is stabilization of blood glucose. Without the repeated spikes and crashes, insulin stops being released in large reactive surges. Baseline insulin levels begin to drop. For people who have been consuming significant amounts of added sugar, the first several days may include withdrawal-like symptoms, irritability, fatigue, headaches, and cravings, as the brain adjusts to the absence of its frequent dopamine signals from sugar. These symptoms are real and neurological, not imagined. By the end of the first week, research suggests that insulin sensitivity begins improving, meaning cells start responding more efficiently to lower levels of insulin. This is the foundational shift. As insulin normalizes, the suppressive pressure on Leydig cells begins to ease. The cortisol rhythm also starts stabilizing without the repeated blood sugar crashes demanding emergency responses. By week 2, most people report improved sleep quality, a development that carries enormous hormonal significance. The majority of daily testosterone production occurs during deep sleep, in synchronized pulses tied to sleep architecture. Even partial improvements in sleep depth at this stage can produce measurable increases in morning testosterone levels. Section 6. Weeks 3 and 4. the hormonal rebound. Continuing through the timeline, the changes that occur between days 15 and 30 represent the point where the body's hormonal recovery becomes measurably significant, rather than merely directional. As visceral fat begins to mobilize, the body accessing its stored abdominal fat for energy in the absence of a constant sugar supply, aromatase activity decreases. Less aromatase means less testosterone is being converted to estrogen. Studies suggest that even modest reductions in visceral fat produce disproportionate improvements in testosterone to estrogen ratios because the enzyme activity declines faster than the fat itself. Research examining men who eliminated added sugar and refined carbohydrates for 30 days consistently shows increases in free testosterone, the biologically active form not bound to carrier proteins, and therefore available to act on muscle, brain, and bone tissue. The increases are not pharmaceutical in magnitude. They are meaningful, however, and they occur without any supplementation, purely through the removal of a suppressive variable. By day 30, the cortisol rhythm in most people has normalized considerably. Sleep architecture has improved. Inflammatory markers, which independently suppress testosterone production, have begun declining. The body is not yet fully recalibrated after 30 days. But the direction is unambiguous, the mechanisms are active, and the foundation for continued hormonal recovery has been genuinely established. Section 7. What supports testosterone recovery? The evidence-based stack. With the hormonal pathway now clear, let's address what the research says about accelerating and sustaining this recovery. Because removing sugar is the foundation, but it is most effective when built upon. Sleep is the single most powerful lever available. Studies show that restricting sleep to 5 hours per night for 1 week reduces testosterone levels in young, healthy men by levels equivalent to 10 to 15 years of aging. Protecting 7 to 9 hours of quality sleep, with particular attention to consistent sleep timing, which governs the circadian regulation of hormone release, amplifies every other intervention significantly. Resistance exercise, weight training, or any activity that places progressive mechanical load on muscle directly stimulates testosterone production through multiple pathways, including increased Leydig cell sensitivity and reduced sex hormone-binding globulin, the protein that binds testosterone and renders it inactive. Even 2 to 3 sessions per week produce meaningful hormonal effects. Zinc and magnesium are the 2 micronutrients most consistently linked to testosterone in the research literature. Both are commonly deficient in populations eating processed, high-sugar diets. Zinc is found in oysters, red meat, pumpkin seeds, and legumes. Magnesium is abundant in dark, leafy greens, nuts, and seeds. Vitamin D, technically a hormone precursor itself, shows a strong positive correlation with testosterone levels in studies, with deficiency common in low sunlight environments and high sugar dietary patterns. Section 8. The bigger picture. Hormonal health as a system. Here is where the science leads us to a conclusion that extends well beyond testosterone specifically. Because what this research ultimately reveals is that hormonal health is not a fixed biological inheritance. It is a dynamic system that responds, often rapidly and measurably, to the chemical environment you create through daily choices. Sugar's suppression of testosterone is not an isolated quirk. It is a window into how profoundly metabolic health and endocrine health, hormone health, are interwoven. Insulin, cortisol, estrogen, testosterone, and growth hormone do not operate in separate compartments. They are nodes in a single interconnected network, and chronic dietary sugar is one of the most consistent disruptors of that network operating in the modern world. The person who removes added sugar for 30 days and sustains that change does not simply have better testosterone numbers. They have reduced insulin resistance, lowered chronic inflammation, normalized cortisol rhythms, improved sleep architecture, and begun reversing visceral fat accumulation. Each of those changes reinforces the others. The hormonal system, given the right conditions, has a remarkable capacity to recalibrate itself. This is not a story about an extreme intervention or a rigid protocol. It is a story about removing a single pervasive suppressive variable and watching the body remember what it was designed to do. The research is consistent. The mechanism is clear. The only question is when you decide to run the experiment on yourself.